The Art of an Approximated Science by Francis T.S. Every applicable science is approximated. Why applicable sciences are approximated? Since physically realizable science has only one reality that cannot be repeated, yet all applicable sciences are approximated and can be repeated. This is precisely why every homework problem in textbooks have a solution, because they were pre-constrained, for example, by linear spatial invariant assumption. Yet those deterministic solutions are approximated. Again, an approximated solution is not a physically realizable solution, since our universe has only one physically realizable reality that cannot be repeated or approximated, as depicted in Figure 1, which is precisely the reason why an instantaneity, that is t=0 consequence, cannot be exploited for application. Figure 1 shows our universe is an energy-conserved, dynamic expanding subspace, where every physical reality occurs only once, which cannot be repeated. What is a physically realizable science? Since every physically realizable science has only one consequence, for which fundamental laws of physics cannot have a paradox. Yet Schrödinger's quantum theory does allow two simultaneous solutions to exist that violates the law of non-paradox in science. Nevertheless, his cat has many possible reasons to be killed or not to be killed. Yet he has cleverly created only two possible scenarios for us to select. This is precisely why his quantum theory had misguided us for almost a century. Since every physically realizable reality can only allow once at a given time, this means that his cat cannot be alive and dead at the same time. In other words, every physically realizable consequence can occur only once, but not at the same time, from which we had seen that Einstein's relativistic mechanics, Schrödinger's quantum mechanics, Dirac antimatter mechanics, and many other fundamental mechanics are not physically realizable, since they had first violated the law of temporal, that is t=0. The art of a repeatable science. Since our universe is an energy conservation dynamic subspace, its entropy increases naturally with time. We see that every physically realizable consequence emerges only once but cannot be repeated. Even a quantum leap from an atomic particle must be unique that cannot be repeated or simulated. But those are strictly from physically realizable standpoint, since we cannot have two twin brothers of the same person, or one cannot produce two same-trademarked cars of the same car. Nevertheless, to mention, if the same trademark cars are considered as different cars, then the same trademark cars can be repeated, of which we see that every applicable science can be repeated, in which every applicable science is repeatable and approximated. Why physically realizable science cannot be approximated? Since our universe is an energy-conserved dynamic subspace, it permits only one physical reality of absolute certainty at current time t equals 0, of which every physical reality that happened within our universe cannot be repeated. Secondly, our universe is a temporal subspace, that is, t greater than 0. Its pace of time cannot be approximated, although mass, energy, velocity, and other quantities may be approximated. Since the current moment, that is, t equals 0, is the only moment of physical certainty that cannot be repeated, in which the pace of time must be this, is the only variable that cannot be approximated. Why applicable sciences are approximated. Since applicable science does not need to follow physically realizable constraints, they are repeatable. For instance, identical trademark cars are repeatable, but they are not the same car. This is precisely why physically realizable science cannot permit paradox, but all applicable sciences can, for example, two identical twins. This means that applied physics is a repeatable science, but physically realizable physics cannot be repeated, for which it is wrong to assume any physically realizable consequence as an applicable science. For example, your bicycle cannot be repeated as the same bicycle, but bicycles of the same brand can be repeated and thus approximated. Approximation is an important attribute for all repeatable sciences since they are approximated. But many mathematically oriented scientists do not know that a physically realizable science has only one physically realizable consequence that cannot be repeated. And this must be the reason that mathematically oriented physicists treat physically realizable physics as a repeatable science. For examples, there are relativistic mechanics of Einstein, quantum mechanics of Schrödinger, and many others. They cannot be approximated since they were mathematically created, virtual, or even fake. Is an ounce of good approximation worth more than tons of calculation? Although approximated sciences are true scientists, which have been accepted for all applied sciences, but they are not true from a physically realizable standpoint. For example, why does every problem in a conventional textbook have a unique solution? It is because all textbooks have been pre-constrained, such as a linear, spatially invariant space. However, our universe is not a linear, spatially invariant space. Every subspace changes with time. Since our universe is an energy conservation dynamic subspace, everything degrades with time. This is exactly why entropy within our universe increases naturally. It is because that our universe is constantly degrading its energy, for example, doing work. For example, longer anticipation is more uncertain to predict. Yet a good approximated solution is acceptable, and this must be the reason that all applicable sciences are approximated. Since violating any law of nature is not permitted, for which it is wrong to approximate the pace of time or to change time, as Einstein had promised or Schrödinger instantaneously superimposing two particles at the same time. Everything is limited by delta E as a function of time. Nevertheless, everything within our universe is limited by an amount of energy, delta E, in each section of time, delta T, that created it, by which as entropy increases with time, as its section of time, delta T, enlarges, for which everything within our universe has a lifetime, where we see that as its delta T extends very large, that is, to infinity, its total amount of energy that created the thing degrades within the subspace. Since E0 is energy conserved, that is active mechanics, it decays or degrades naturally with time. Nevertheless, energy degradation can be rapid or slow depending on the nature of E0. For example, an explosive mechanics that could be very rapidly degraded as doing work, in which we see an amount of energy is released to its energy degradation, for which every subspace within our dynamic universe is like an explosive machine or even a bomb, where an amount of energy is released as its entropy increases. This is precisely why every experimental test is anticipated to have a physical response, regardless whether we want it or not. But the response is by no means a yes or no answer, since every experimental setup is a physical thing, that is mechanics, and its entropy increases naturally with time. What is a time signal? Since everything within our universe needs an amount of energy delta E and a section of time delta T to be created, as depicted in Figure 2, where E0 is the total energy. It is the signal energy delta E that degrades with time as delta T enlarges, and its total energy E sub 0 is conserved. Nevertheless, a time signal without a section of time delta T is not a physically realizable time signal, since every time signal needs is not just an amount of energy delta T within a section of time delta T to represent a time signal, but it is the total conserved energy of E sub 0, in which we see that delta E degrades as delta T enlarges, which is due to its entropy increasing with time, by which every time signal is equivalently equal to an energy conserved dynamic subspace as illustrated in this figure, where we see that a signal energy degrades as it travels with time. Figure 2a shows a signal having no time width. 2b shows an energy time signal moving with time. Figure 2c shows a wavelet moving with time. In conclusion, I have shown that the pace of time neither can be approximated nor changed. Since the creation of our universe cannot be initiated without time, this must be the law of temporal that initiated the creation, that is, t greater than 0, for which time cannot be simply created by mathematically oriented or illusional physicists. Time must have existed before the creation, and that is one of the best postulations instead of a hypothesis, in which we see that every physically realizable physics has only one consequence at a given time, which cannot be repeated. for this must be the approximated sciences that can be repeated. Since all mathematical deterministic sciences are not physically realizable principles have only one realizable consequence, yet one and only one's consequence is not possible to exploit, since applicable science must be repeatable. Mathematical physics is a deterministic science, but applicable sciences are not deterministic, for which all applicable sciences must be approximated, otherwise science would be a useless mechanics for us to apply. Finally, let me emphasize that it is wrong to treat any physically realizable consequence as an applicable science, since it cannot be repeated. It is, however, a repeatable approximated science that we can exploit. Thank you.